Hey guys, we're talking about complex numbers and now we're working with some operations. So like adding, subtracting, multiplying, dividing, really fun stuff. So if we have complex numbers are a plus bi, and when we go to add or subtract, let's leave that there. So adding or subtracting is just like combining like terms. The subtracting does add an extra element, but the adding, literally you're just adding like terms. So if you see here you got 4 and you have -8, combine that. And then you have 2i and you have 9i, combine that. And what do you get? -4 plus 11i. And then subtracting over here, the only thing is with subtracting, you have to remember that you have to distribute the negative, because you have that negative sign there, you have to make sure that these are opposite signs. So we have 4 plus 2i, that doesn't change. And instead of -8, because we're adding the opposite, it becomes positive. And because instead of positive 9i, we have -9i. Okay. So then from here, you just combine like terms, just like we did over here with the adding. So I have 4 plus 8, that's 12. And 2i minus 9i is -7i. So I combine my like terms, 4 and 8 is 12. And make sure it's always in the form a plus bi like you see here. And then the next section that we need to understand is multiplying. Sometimes it's like a monomial, meaning one term, times a binomial or more. Well, really not more with these. And then it also could be a binomial times a binomial. So all that old stuff that you've been, trying to bring back, it's here. So write this down. We have 3i times 5 minus 2i. Pause the video. And then I'll show you what to do. So you're distributing that 3i to both the 5 and the -2i. 3i times 5 is 15i. And then 3i times -2i is -6i squared. Because it's I times I, that becomes I squared. And knowing our rules about I squared, we have to think about that. I squared, what's that? Oh yeah, I squared is -1. So now we have 15i minus 6 times, where is it? There it is, times -1. Do the math. -6 times -1 is +6. So you have 15i plus 6. But you have to check, is that in a plus bi form? I need my I second. So I've got to switch it to 6 plus 15i. And that is in the right form. Okay? Over here, it's slightly more challenging, but it does simplify out to look the same. So when you have a binomial times a binomial, you have to multiply 5, the other way, 5 by both 6 and 2i. So 5 times 6 is 30. If you haven't written this down, by the way, pause the video, write it, come back, hit play. So then I have 5 times 2i. That's 10i. And now 5 is done. I've multiplied by both terms. I'll go look at the -3i and multiply those by both terms. I'll use a different color because that makes it more fun. I'll use blue. So I have -3i times 6. That's -18i. I have -3i times +2i. It's -6i squared. Okay? And now again, I squared, I have to deal with that, right? I have an I squared, and I have like terms. So basically, I take my like terms in the middle, and I'm going to add those in a second. But let's deal right away with that -6 times I squared. I squared is -1. So -6, right here, times -1 is +6. So really, I have 30 plus 6. What's that? And then I have 10i and -18i. What's that? So notice you're back to the two terms, which you need a plus bi. Which do I need first, just the number or the I? I need the number. So I have 30 plus 6. That's first. 30 plus 6 is 36. And 10i minus 18i is negative 8i. All right. That's my answer. All right, so that's adding, subtracting, and multiplying. All those seem okay. The next part is slightly harder. Nothing you can't handle. So the next thing to teach you about is complex conjugates. Make sure to pause the video and get this down. If you look, a plus bi and a minus, man, I keep blocking it, and a minus bi, I'm just gonna, there we go. Those are considered complex conjugates because they are the exact opposites. And the fact is that the product is always a real number. So it's super helpful, and this is what we need in order to divide and deal with i's in the denominator. So let's start with understanding what a complex conjugate is. So basically, say I have 5 minus 3i times 5 plus 3i. Then you're multiplying just like we just did. Ooh, right here where you multiply all terms, right? So you get 25 plus 15i because you're doing 5 times 3i. And then negative 3i times 5 is negative 15i. And negative 3i times positive 3i is negative 9i squared. So then from there, if you notice the middle, positive 15i and negative 15i, it cancels because they're opposites, right? So that middle is gone. And then we got to deal with over here, I squared is negative 1. Negative 9 times negative 1 is positive 9. And again, we had 25. So 25 plus 9 is 34. So again, the product is always a real number because the middle will cancel. So you're just left with 34. So using this fact, last thing to talk about is dividing. All right, almost done. So the fact that we know, that we need to know, is I cannot be in the denominator. So I'm going to give you 2 examples. One example is when we have just a pure imaginary number in the denominator, like just I, not 2 terms, 4i, 7i, right? Something like that, how you would deal. So let's say we have 15 over 2i. To get rid of it, you multiply the fraction by I over I. Okay? Make sure you pause the video at any time, and then you can keep moving. So when I do that, I'm going to move this. So when I do that, I multiply by I over I end up getting 15i. It's getting blurry, so I'm shaking. You end up getting 15i over 2i squared, right? You multiply straight across. And I know I squared is negative 1. So I have 15i over 2 times negative 1, which is negative 15i over 2. And that's it, right? So it's kind of easy when it's just like an I in the denominator, not 2 terms. And now I'll show you the hardest one of when it is 2 terms. So let's say we have a complex number like a binomial in the denominator. For example, negative 3 over 2 minus 3i. So that's why I taught you this complex conjugate, so that you could use that rule so you can deal, because otherwise there's no way to deal with this. So what we do is we multiply, reading right here, multiply by the complex conjugate. So this 2 minus 3i, what's the same but opposite, right? So we're multiplying by 2 plus 3i in both the top and the bottom. And then we got to multiply. So back to multiplying our rules, right? For that, you have 3 times 2i, 2 plus 3i. And in the denominator, you're going to distribute each and every part. 2 times 2 is 4. 3i times 2 is, I messed up. 2 times 3i is 6i. It's fine, because they're going to cancel. 2 times 3i is 6i. Negative 3i times 2 is negative 6i. Notice how they're the same but opposite, so they will cancel. Okay, so that says 6i and negative 6i. And then the I squared turns into negative 1. Negative 9 times negative 1 is positive 9. 4 plus 9 is 13. And then the numerator, we just multiply 3, negative 3 times both of those, and you get negative 6 minus 9i over 13. All right? If that was confusing at all, just talk to me. Okay.